day of algorithmic trading with AI and Python. We've got to wrap it up. We've got to wrap it up today. Also, we've got a lot of things to take care of on a Friday here, so we want to make sure to make this one. We got to be productive. We got to be productive now because we only have an hour. We've got about an hour, so we're going to we've got just a few tasks. So we need to clean up this list. We need to make the AI usable, a little bit more usable. If you want to leverage the AI yourself, then we'll make it really simple. We'll make it really simple to use. So all right. So we already achieved some of these things here. So we calculated the cost. That was done. We saw a really good outcome here. That was really neat. We also separated training data from sample data. So let's see here. Let me see if we can add that in on this list. We separated training data and validation. So we separated that. We got that working, and it works. And you can see that it is very satisfying. What we need to do is the whole plan for today. The last thing that we got to do is wrap this up into a more consumable. We have to save the model. This is what we have to do. All right. So let's add this. So let's see. Save and load model. So we'll have a separate. What we'll do is we'll have a separate file. Maybe that we could do it'll run the test, and it'll make it really easy. If someone wants to pick this up and start making profit, because look at the results. Look, this is the future. What you're seeing right here is really satisfying. Thank you for all the likes. Are they at risk? I think no. Here's the deal. So the existing AIs that are able to write, what I'm going to do is I'm going to make it a little bit easier. We're going to train a model, and we're going to save the model so that way you can just load it straight up. Because I've got a really powerful GPU over here, and it trains the model off of it. And so I'll save the best iteration. I'll save the best one. We'll put it on GitHub, and then you can use the model and load it directly. And then now you can directly use it, and you can profit from it if you want. I'm not going to do it because I have gone down that road before and have been successful, and it consumed everything. And it turns out I can do other things that make I can be successful in other ways. Let's just put it like that. I can be successful in every. What are you predicting? Oh, stock prices. We're predicting stock prices, and we did a really good job. So it's algorithmic trading AI. This is a medium frequency trading. It's not high frequency trading, just medium frequency over every 5 minutes. So it'll over a 5-minute window, and we have 3 output tokens. Here's what we did. So we're doing algorithmic trading with AI. What we've got is we're targeting a volatile market with lots of news events so that we have a lot of training data and a high volume of trades. We need high volume because when we place our market order, we want to make sure that it goes through and it doesn't get partially sold, right? We want to buy or sell. We want everything to come through all at once in the volume that we're looking for without it having to be parceled, right? We don't want it to be parceled, which causes loss in performance on your earnings. We're using YFinance as the data source, PyTorch transformers as the library and the model, Gemma 300 million parameters embedding model from Google, which is the world's most state-of-the-art open source embedding model. Basically, it captures semantic meaning from our data. It captures the semantic meaning from our data, and then we can use that as the input to our model. We can use that as the input of our model. And we're using scikit-learn for the F1 score to determine, is it good quality? Is it good quality? Yes, it is. You can see they are beautiful quality. It's excellent. And so we've got one important task. I want to save and load the model. So let me jump over here. So I need to, how do you save the model in PyTorch? Okay, PyTorch save model to disk. Let's see, how do you do that? I know how to do it if I was doing my own custom model. All right, so here we go. We just say torch.save model state dict. Okay, that's it. That's all we do. All right, we can do that. Let's see, print saving model, and then we'll just say local path. The file name. Okay, PTH. Okay, so this is called. Okay, perfect. Gemma transformer classifier. I think this is good. It's meaningful and it makes a lot of sense. All right, let's run it. Let's run it and see if it works. All right, let's run it. There we go. Here's the model. It's running. So we've done a lot of things to improve this model. So we cache our embeddings as well. So after the first epoch, it gets a lot faster. After the first epoch, as soon as it gets through 100% of the data. At least 80% of the data. See now it's running. See how fast it's going, isn't it cool? Like, see how fast. Did we save the model? We saved the model. All right, let's see here. Let's see what it looks like. LS, what does that model look like? Gemma embedding, it is 1.2. It's over a gigabyte. Oh no. That won't fit. That won't fit in GitHub. We can't do that. GitHub will not let that work. GitHub says that's too big. Man, I love your energy and the enthusiasm. You definitely have to the effect motive around those around you. Cool. It's so cool to hear. Thank you for saying melodrama boy. Thank you for mentioning that. Yeah, we've got so many great things to talk about and so many great. I'm really excited. So some of the upcoming streams. Let's see if we can do this. So we need to open up the PyTorch file. So let's see, train. Let's go into train, and then let's open up a new file called test.py. All right, and so we need to load the model. So let's grab this here. Let's copy and paste these things up here. All right, we need to load the model, and then we want to do a test. I want to basically reproduce this right here. This is what I want to reproduce, this part right here. So then we can load in the model. We don't need to save it. We're just going to test it. And then we need to pull in the test data. So let's see how we can do that. Let's pull in the test data. Where is that at? Okay, so here is features labels. Okay, so we open up this. Here we go, features labels. And then we will grab the test. We read the data, grab the data, pull in the data, capture our test features. We don't need the train features. So we're grabbing those. And then we don't need this anymore. We don't need that. We just need to evaluate the model now. Here we go. So we should be able to do that. Here we go. All right. So we've got our classifier forward. Yep. Looks good. Happy with that. Okay. Model. Got it. Okay. So we grab that. Okay. So we need to reinitialize it, and we load the state dict. Okay. So we basically just have to do this. I think that's it right there. That's what we got to do. Okay, perfect. I think we can do that. Hey, Braun, how's it going? Welcome on in. Happy to have you here. Happy Friday. We're on the final stream of our algorithmic trading AI with Python. We're on the very last day. Okay, so we're going to see where did we do the model at? Where's the model at? Let's see here. Blurp. Oh, no. We must have deleted it by accident. Okay, let's see here. Let's grab that. Okay. We need to reinitialize the model. Let's see how we do that with the train here. So let's look for model. Okay. This is what we need here. There we go. So model, and then we just load, it like this. That's it. That's what we got to do. So now we've got it. Now we've got the data. We've got our features and labels, and then we should be able to load the model. I think that's it. This is like the one thing that we had to do. This is one thing that we had to do today. All right. So let's save that. Let's see if we can run Python test. Is it going to work? Oh, it looks like it's working. Is that it? Is it going to work? I think it might. Did we achieve? Oh, no. By is not defined. Oh, okay. Got it. Okay. 1 second. We're missing some. We got to include the tokens. It doesn't know what the tokens are. We got to include the tokens. Train by BUI. Grab the tokens. There we go. All right. So here's our tokens. Define our labels, or basically tokens, right? So, tokens. Yeah, and our token. There we go. All right. Let's see here. Let's try again. Let's see if it works now. Problem is the MPS in the device. So I need to auto detect a device. So let's see if we can get an AI to help us with that real quick. All right, let's reload that. Let's do how to auto detect best device. Let's see, and then we're going to paste that. So right now we're using MPS, but not everyone has that. Not everyone has it. So let's see here. Get best device. Perfect. This is what I want. I want this little function here. Let's copy and paste it. We'll copy and paste it. All right. So here we go. Get best device. Excellent. All right. So what we can do is we could probably put that in this class here. Let's put it inside there and have it automatically use the best device. We'll do that. We'll put it right there and have it automatically use the best device. So let's grab this. We'll go into models. We'll open up the model. We'll let's see. Set paste PST, and then we will paste this in. So now we've got to get best device, torch.device available CUDA or MPS or CPU, right? So we'll get that, and so it'll work on any system now. We'll want to make it work on any system. So init device option none, but we want, instead of none, we want it to get the best possible device. Instead, I'd rather just set it here. I think we'll just do this. We'll do get best device. That's what we'll do. We'll just say get best device, and then we win, and then we don't even need this here, and we don't even need that. We'll just do this. There we go. Boom, just like that. Get best device, and then I suppose we'll delete that, and now we're done. We want to get out of there. Let's get out of there, and then we want to train, and then we want device, and we need to delete it. There, done. All right, I think that's it. I think we did it. All right, so now it's automatic. It's automatic. Get the best devices automatic. Okay, I think that's all we need to do. Boom. All right, now it should work. So now we should get a good score, and it should be deterministic now, right? Using Apple, yep, MPS device, perfect. So we should see the same accuracy results. We should see exactly the same. Is it the same? Yep, looks the same. All right, we're good. All right, so we achieved that. Now we're wrapping this up. What else can we do? So we achieved this goal here. We're good now. Let's finish writing this. Okay, so train the model. Might require changing you want to change some hyperparameters, changing parameters in the script. So you might want to change parameters in the script. It won't require, but it will recommend modifying some of the parameters if you want. If you want, modify. Okay, so we got download data and train, and then Python test the script. Done. Usage guide, training and testing. There you go. And see, model trains on 80% of data and tests on 20% of the data. That's what we did. Rare footage of a programmer finishing a project. I know. Well, technically, I mean, in a way, we're wrapping it up, so we can kind of say it's usable. It's actually usable. So excited for the first trade with our AI. Yeah. Oh, so so this is the last day. It only goes so far. Mohammed, I know it would be really exciting. You gotta be careful. Be very careful. So this algorithm, I'm very confident in it, and I would be able to make money on it. I'm not going to do it. And it's because it's very consuming. If I start doing it and I start seeing money being made, I'm very, it's something that captures my attention a lot. It captures my attention a lot. So I've got the code. You can see it there. It works. It does a good job. And we're good to go. So you can see here the outputs looking really good here. You can see the results, the F1 score right here. We're looking excellent. Phenomenal numbers. It'll work. It'll definitely work. So if you want, then you'll have to download it and run it yourself. I made it work on your computers too. So I made it work on your computer. It will load let's grab this. So it'll work on any of your hardware accelerators. So if you have a NVIDIA or CUDA compatible accelerator, it'll run on CUDA. If you have a Mac, it'll run on your Mac Silicon, or it'll run on your CPU if you don't have any of those things, which is good enough. And it's only a 1.2 gigabyte model. So check this out right here. So this is our model right here. Right here. Isn't that crazy? It's crazy. It's right here. This is the model right here. So it's available. It's available to you. If you ever want it. It's right there. QA. Wait, hold on. Q. There we go. So check this out. LS right here. It is where is it? Where'd it go? Here it is. It's 1.2 gigabytes. So you can see right here. It's pretty big. It's a pretty big model for what it's doing. But here it says 1.2 gigabytes right here. Right there on the screen. 1.2 G, you guys. What strategy you're using? Conrad, Major 8695. All right, Conrad. The strategy we're using here is volatile market, lots of events and news, and high volume trading. So that's the target symbol that we're going after. This is our libraries. We're using YFinance, PyTorch, Gemma embedding for the sentiment and the semantic meaning of the data that we're feeding it. And we're targeting these symbols because they match our criteria. Historical data prices is the input, and the news headlines with any potential foreign policy events that occur at the same time. And then our outputs are 3 tokens. 3 tokens are outputs that look like this. Buy, sell, and hold. Those are our 3 output tokens. It looks like this right here. And that's about it. So we've got it trained. It is the kind of training that we did was, wait, hold on. Let me zoom up on my screen brightness there. Okay. We did supervised learning. We didn't do reinforcement learning, though that would make that model better. Let me add this here. Let's add reinforcement learning. That's another thing that you could do. So the model could be improved if we did these things. We're not going to do these things because we're out of time. We're wrapping it up. We're finishing the last stream ever for our algorithmic trading AI. We might do it again in the future, but we achieved what we were looking for. We could go forth. Thank you for the likes, you guys. Thank you for the hearts. We need to install this. All right, let's do that. So we're going to install this real quick. We're going to install it, and then I want this to go on GitHub. I really do. I want it to go on GitHub. I think it would be really helpful if we gave you the model directly. Okay, let's see if we can rerun it. All right, so done. Okay, now let's track. Let's do a track. All right, so how do we track it? Let's track all of certain file types. All right, so ls. We'll track all PTH files. PTH, there we go. I think we can get this model on GitHub, and if we can, that means everyone will have access to it because we trained it on our hardware. And it's a 1.2 gigabyte model, which means that it will be very difficult to train if you don't have a specialized hardware. So if we save this for you and then you can use it, and you can get this level of accuracy, that means that 80 is basically 83%. Thank you for the likes, you guys. 83% of your trades will be perfect accuracy, which basically, if you want to gain money, you have to make sure that you're above 50%, right? Otherwise, it's just a random flip, right? It's a random flip. But 83%, pretty good for predicting future data. Isn't that cool? I think that's really good. This model is going to be available for you for free on our Discord. It's on our Discord, you guys. On our Discord. So let's see if we can get this here. All right, get status. See where we're at. Git add -- all. Well, actually, before we do that, let's add the other things. README, model, and train. Train and test. Test. There we go. Get status. Vi.get attributes. What is this? Is this? New. That's a new thing. Git add.get attributes. All right. Status. All right. Git commit. Added. Easy mode for anyone to run the model yourself. Exclamation point, party popper, done. Push to main. There we go. All right. Now, thank you for the likes, you guys. Thank you for the likes. Now it is available. Oh, is it good? All right, we're good. Okay, here we go. So now let's see if we can add the model itself. This is the last thing we got to do, and then we can. It's almost there. So the model, the test, and the train, good to go. If you want to take this and you want to start profiting from it, you need to do a couple of things. You want to look at the test file, see how it pulls in the data, and then you need to basically create your own separate script, the separate script that will connect up to YFinance WebSocket. We might be able to add that in as well. For you. And then it needs to call the YFinance News API to capture recent news events. Collect that data, transform it into the data that the model is looking for, and you can predict the future. And then you can predict the future. That's it. That's what you got to do. We did it. We were succeeded. That was previous stream. That was yesterday. And we showed that it worked really well. This is the model that you guys want because is it working? It is. It is working. Well, actually, I don't know. I don't know about this part. But the model works. And so we're about to give the model away. Everyone, the model will be available to you for free. Here we go. Git commit. Added the model weights and biases, which is basically the parameters, parameters. There we go. All right, it's available to everyone for free. Hopefully it works. I don't know. We'll find out. Boom. All right, is it going to work? Push main. Is it going to work? We'll find out. It's got to upload 1.2 gigabytes. So, it's working. You guys, look, it's working. It's uploading. Here you go. Here you get the model for free. Fully trained 1.2 gigabyte super parameter model that can do your own algorithmic AI trading for using Python. It's working. It's going to take a while to see how far we got. Oh, it looks like it's almost done. It says 1.2 gigabytes. That's basically it. That's how big the model is. It's 1.2. Oh, we did it. It's there. We did it, you guys. Okay, so it's for free now. It's available. You guys can grab it. Let's confirm that it's there. Let me check. Pop it up over here really quick, and then I got to get running. GitHub Steven. All right, let's look here. Pulling that up under repositories, and I'm gonna double check algorithmic trading with Python. Here it is. All right, here we go. This is it right here. Is it there? It's right here. There it is, you guys. Boom, right there. Gemma transformer classifier .pth 1.2 gigabytes. Get ready to download a pretty decent sized model. You know what? And then it'll do all the things for you. So we added the instructions here to the README. So you got the README instructions here. So you install your requirements, pip install requirements. You want to download data. You want to train it. If you want, you don't have to do the training. This is optional. You don't have to do this part because we already gave you the model. The model is right here. The model's right there. I need to update the README real quick. I would suggest you to continue on the actual market performance trading using this, because if it's really 1%, then that would compound heavily really quick. It could. Yeah, you're right. I didn't even think of that. Yes. So it would grow. It would grow, right? So if you kept your account growing, but it's based on how much you place your trades for. So it's less, it really depends. So you would have to make some updates on your own. You would have to make a few updates. You're right, it would compound though. So Maya, you're right, it would.